We'll now look at finding a domain of the function f of x equals to 1 over the square root of x minus 9. So notice that this is a rational function, and for any rational function there is a restriction where the denominator cannot be 0. Okay, so for any rational function the denominator cannot be, and in addition, since we have a square root must the radicand must be positive. So that means that the square root of x minus 9 has to be greater than 0 because it can't be 0. So if we now solve for x, so x minus 9, the square root of that greater than 0, if we square both sides, that leaves me with x minus 9 is greater than 0, therefore x has to be greater than 9. And if you look at that, if you look at this here on the number line, okay, if you look at it from the number line, if you test any number below, okay, if you check 1 over the square root of x minus 9, if this is f of x, what is f of, let's say, 9? Well, f of 9 will be 1 over the square root of 9 minus 9, which is equal to 1 over the square root of 0, which is 1 over 0, and we know that this is no. Okay, so that's why the domain has to be a number greater than 9. So in interval notation, that will be from 9 going towards infinity. So that means on the number line, anything from 9 and bigger, will be the domain. So in the next problem we look at is you're given an equation and you're asked whether it represents y as a function of x. Now if you notice, and if you are thinking, you will observe that this equation is in the form of x minus h squared plus y minus k squared equal r squared, and this is a circle, and we know circles are not functions of x. Now how do we do it algebraically? So algebraically, what we'll do is solve for y. So if we have x minus 5 quantity squared plus y minus 2 quantity squared is equal to 81, we'll move all of the x to the other side. So then we have y minus 2 quantity squared is equal to 81 minus the entire parentheses. And we don't care to expand what it is. Now get rid of the square. So now we'll take the square root of both sides. And if we take the square root of both sides, that will give me plus or minus on the other side. And right here you will see that this is a problem because you cannot have a plus and a minus. So we're left with y minus 2 is equal to plus or minus the square root of 81 minus x minus 5 quantity square. And you can stop here if you want. Or you can say that y is equal to plus or minus the square root of 81 minus x minus 5 quantity squared plus 2. And here you will say this is not a function, not a function of x, since we will have two outputs for each input. That means that every time you plug in an x value, if you plug in an x value here, you will have a positive and a negative result. We're now looking at whether the function is even, odd, or neither. So to save time, so you have to perform to find out which one, and we know it could be even, it could be an odd, or it could be neither. So if we look at even, you should recall that for even, f of minus x will be equal to f of x. Well, we have b of x, so in our equation we can say that b of minus x must be equal to b of x. And let's see if that is true. Well, b of minus x will be equal to minus x to the 6th power minus 2 times minus x to the 2nd power plus 3. Well, minus x to the 6th power is the same as if I have x to the 6th power. Because if you take anything negative and you raise it to the 6th power, it will give you the same as if it's positive raised to the 6th power. Minus 2, and likewise over here, this becomes x to the 2nd power plus 3. So now this is exactly the same as our b of x. So b of minus x does give us b of x, so this implies that the function is even. And notice if it's even, we don't have to check for odd or neither, okay, because it can be even and odd at the same time. In part B, we'll check for even again. So for even, we know that g of minus x must be equal to g of x. So what is g of minus x? Well, g of minus x is minus x times the square root of 8 minus a minus x squared. So g of minus x here is equal to minus x, the square root of 8. Now be very careful, minus, which will be this minus here, and if you square a negative, you will still get it as if it's a positive. So notice that this here is our g of x, but g of minus x is equal to the negative, which is this negative here, g of x. So this implies that this function is odd. Because remember, recall, for odd, g of minus x must be equal to minus g of x.